LeetCode problem number 695, max area of island. So this problem gives us a m times n binary matrix grid, and in here it explains what an island is. Basically, it is a group of ones connected 4 directionally, horizontally, and vertically. And we can also assume the 4 edges of the grid are surrounded by water. So I mean here is areas over here, for example, are all surrounded by waters. Okay, our job is to return the maximum area of an island in the grid. And if there is no island, we can return 0. So this problem is pretty similar to the problem number 200, count island. But instead of counting how many islands there are, we will instead need to keep track of how big of an area each island we visit are. So using the same concept, we are using a flood field again. So inside the flood field, it is our boundary checking. So we are checking whether or not we are going above or below the grid sizes. And here we are also checking whether or not we are on an island or not, right? So this part here, because the islands are either ones or zeros, right? It is an integer. So once we have visited a cell of an island, we will mark it as visited by marking it as 0, which is technically water. And here, I pass in the current. So this current basically stores the current size over here. It is passed in by reference. So current technically will increment for every cell we visit in that island. Once we have done that, we update the max area, which is over here. We update the max area, checking whether or not the current area is larger than our max area recorded. If it is, this max function will return the maximum number between these two. Once that is done, this is where we do our depth first search. We will explore the rest of the grid by decrementing and incrementing the row and column values. Okay, so in our max area of island function, as I mentioned, there is a current integer here, and here we have a double for loop, one nested for loop. So the purpose of this is to iterate through every cell of the grid until we have reached a cell that is an island, right? So let me run you through what will happen when that happens. So for instance, current, let's max area first, and then we have current. So when we iterate through every cell, let's say we visit this one, and now we are on 1, right? So when that happens, we enter the flood field. It falls within our bounds. We make this into 0. Increment the current. So current now is 1 from 0. It's now 1. And then update the max area. Once that is done, these 4 recursive functions will check the areas above, left, right, and below to check whether or not there are adjacent islands. In this case, there are not, so we can just move on, right? So we'll move on recursively, not recursively, but iteratively, finding the next island, which is over here. And what it will do is it will check for all the islands here, updating our current to 4, which will then change our max area to 4 as well. And then once that is done, we would just move on to the next island, right? So this will happen for all the islands until we have reached the bigger one, the biggest one in this case, which would be 6. So current here will increment until 6. We increment until 6, and then we should update our max area to 6 as well. Once that is done, and we had visited all of the islands, then what we will do is return the max area, which in this case would be 6. Okay, so this is another relatively simple problem to solve. If you're not entirely sure how the flood field works, I've explained it a lot better and more clearer in problem number 200, count islands. Other than that, nothing about the logic actually changed. It's just that we are looking at the max area instead now than to count how many islands are there. But that's it. That's all I have to show. Thanks.